In today's lessons, we're going to look more at the equation of the tangent itself. So we've been talking about IROC and rate of change and gradient, and all those things refer to the slope of your tangent. So let's pretend for a second we have this function, and we talk about the tangent at a single point. Okay, I can find my equation that will give me that, my derivative, if you will. But maybe I want to know something about this line itself. I want to know its equation, mx plus b. Well, to figure that equation out, I need to know its slope. I need to know y-intercept. And we're going to work through some of those problems today. So just to get warmed up, just a reminder from yesterday, can we find and interpret f prime at 1 for fx equals 2x5? So what are we asked for here? Well, the fact that we're asked for f prime tells me I'm looking for my derivative. So we'll start off by finding our derivative. And our power rule yesterday said, oh, how did that happen? We can bring the 5 down, multiply with the constant in front, so we'll get 10x and subtract 1, and we get 4 as our exponent. So there's our derivative for any point in this function. This is a quintic, right? 1, 2, 3. Oops, I got 1 too many there. 1, 2, 3, 4, 5. And I want to know what's happening at 1. So to figure out what's happening at 1, I can substitute 1 in. 10 times 1 to the 4. And I can say at 1, maybe 1's right here, let's pretend. At 1, the steepness of that line, the steepness of the tangent is 10. And the function has a slope, an IROC of 10, of 10 at the point x equals 1. Okay, that's what's happening there. So, as I said, we're going to look at some equations. To find slope, we have to use our derivative. To find the y-intercept, we need to know a point on the graph. So we're going to be going back and forth between our two equations, our original function notation and our new derivative notation. Okay? To find points, we use the function. To find slope, gradient, we use the derivative. Those two ideas will allow us to find the equation at any one point. So look at this example here. We have a parabola, basic parabola. I want to know what's happening at -1. I want the equation of this line. So what do I need? Well, I need to know where do I actually hit that curve. Let's see what happens at -1. So I use my original equation. I'll get 1. So I know for sure that this point right here is the point -1, 1. I also need to know the slope at that point. So that means I need my derivative. The derivative of x squared is 2x. And that's the slope at any point on this curve. I specifically want the slope at -1, so we'll plug in -1. We'll get -2. So if I want to find the equation of that line, the mx plus b of it, I know y equals m, it's -2, plus some b. In order to get b, I need to know a point, and we found our point over here, right? -1, 1. So 1 equals -2 times -1 plus b. 2 plus b, 1 minus 2 is b, -1 is b. So the equation of that tangent, that specific one tangent, would be -2x minus 1. And remember, the idea is we can use derivative to find tangent at any point. This is just one of the tangents to this curve. Okay. A related idea is another equation that's called the normal. The normal is the perpendicular to the tangent. So, for example, we have this line that goes right here. This would be my tangent at A. Well, the line that goes this way would be the normal. They go through the same point because we're talking about a single point on the graph, but they are perpendicular to one another. So there's always this right angle here. And so if we can find a derivative, we can find our slope at A, then we can find the slope of the normal. All we have to do is take the negative reciprocal. So let's say we took the same question, and I want to find the normal this time. And the normal is useful, and you might recall on normal when we did vectors was a perpendicular line to your line, right? Same idea, we're talking about perpendicular lines here. So we found out in the previous screen that our derivative was 2x, and we found that the derivative at negative 1 was negative 2. So for r's, our perpendicular slope would be the negative reciprocal. Right? Flip it over, change its sign. We knew that the original point, when we put in negative 1, we had negative 1 squared, okay? And that came up to 1. Notice that all of this is exactly the same. That's the same as what you did for a tangent. We're just looking at the normal now. So the only difference is our slope. So we start off with the same idea, y equals mx plus b. And we know the point for sure on this line was 1 here and negative 1 over here. And we had to solve for b. So the only thing that's changed is that we had to use this perpendicular slope. So we get negative 1/2 plus b. And then we get 1 plus 1/2 is b. So 3/2 is b. So we have a different slope and, of course, a different y-intercept. Okay? But remember, they're related to each other, right? They're perpendicular to these two lines. Sometimes the normal is useful for things. Sometimes the tangent is useful for things. It depends on the kind of situation we're dealing with. Okay, so you guys can try one here. I want to find the equation of the normal and the tangent to this lovely cubic function. So what information do we need? Well, we need to know the point. So I know the 2 part. What's the other part? What's the y part? So 2 cubed plus 2 times 2. 8 plus 4 gives us 12. So both of these things, just get a pretend picture of this thing here, are going through the point 2, 12. I want the equation of the tangent, and I want the equation of the normal. And for both those, I'm going to need my slope. My slope comes from my derivative. So I end up with 3x squared plus 2. I specifically want to know the derivative at 2, the slope at 2. So 3 times 2 squared plus 2 gives us 14. So if I'm doing my tangent, it's going to be down which one I'm doing here. My tangent will be y equals 14x plus b. If I'm doing my normal, I use the opposite slope, right? The perpendicular slope. So negative 1/14 x plus b. Both of these are going to use the point 2 and 12. So 14 times 2 plus b. We get 12 equals 28 plus b. There's 12 minus 28 will be b. Negative 16 would be in our tangent, would then be 14x minus 16. And the exact same process for the normal. I'm just using that negative reciprocal slope, the perpendicular slope. And this one unfortunately has more fractions in it, but that's okay. Negative 2/14 plus b. So I end up with 12 plus 2/14 is b. If you use your calculator, that comes up to 85 over 7 for b. And so your normal is negative 1/14 x plus 85 over 7. Okay, so that's the basics. Now we're going to try to do a little bit of problem solving with this. Okay, so I need to do a little bit of thinking. What kind of information am I getting? What kind of information do I need? What kind of information can I figure out? So I want to know in this example, at what point in the function, so we have a parabola, we'll make a pretend picture here again, a parabola. Well, at what point does a tangent have a gradient of 2? So I'm told there's a tangent, I'm told it has a gradient of 2. Well, what does that mean? That means when I draw my tangent, its slope has to be 2. How do I find slopes? If I want to find slopes at any point on this place, on this parabola here, I need my derivative. So my derivative of this function is 2x minus 4. And I want to know when that derivative actually comes out to 2. And that's what that is, right? Derivative is 2. So I can put in answer of 2 and solve for the x. So 2 plus 4 equals 2x. 6 equals 2x. X is 3. I get a slope of 2 when x is 3. Now to ask you for the point, how do I find points? Well, I go back to my original function and plug in the 3. So 3 squared minus 4 times 3 plus 7. So we'll get 9 minus 12 plus 7, and that comes out to 4. So at the point 3, 4, I end up with a gradient, a slope of 2. Here's a little bit of problem solving. Okay, you gotta try the next one. Find a for this function if the tangent gradient of 2 at the point where x equals negative 1. So what are they giving us? Oh, they're telling us the derivative again. They're telling us that f prime equals 2. Actually, in fact, by taking this in, they're telling us that f prime at negative 1 equals 2. So can we try and use that idea? Well, let's see. If I take my derivative, I'm going to get a is just a constant, right? So 2ax plus 6. And they're telling me that this comes out to 2 when x is negative 1. Well, let's fill that in. Well, I've only got one variable to solve, right? I can multiply 2 times a times negative 1 gives me negative 2a. I get negative 4 is negative 2a, so a must be 2. And I've solved it. By recognizing they're telling me a derivative, and they're telling me when that derivative happens. Okay, so you have to sort of process the information that they're giving us. All right, that's more. The tangent to this function at the point negative 3, 8 has a gradient of 9. And what have they given? They've given us an x and a y. They've told me a derivative equals 9. In fact, by giving us a point, they're telling me the derivative at negative 3 is 9. And they want us to find a and b. So what can we do? Let's fill some stuff in. What do we know? We know that f prime, let's find f prime, x, is negative 6x plus a. And they've told us that when I put in negative 3, I'll come up with 9. So I'll put a 9 here, and then negative 3 over here, and solve for a. We only have one variable left, so we can solve for that. So we get 9 equals 18 plus a. 9 minus 18 equals a. Hey, a is negative 9. Great, we've solved that. That's to find a and b. So how can I find b? Well, b is in the original equation, which is made up of x's, right, x's, and a y, and an a. So if I want to solve that, I can because I have this point that I was given. I can put in the 8 for the function value, the point. I can put in negative 3 for the x. A we just figured out was 9. X is negative 3. And now the only variable I'm missing is the b. So if we solve this, and just be careful with our signs and all that good stuff, we'll get 8 plus 27 minus 27 equals b, or in other words, 8 is b. And look, we've solved that variable. And using a little bit of thought, and what kind of information do we have? Do I need the original equation, the new equation? Things like that. Okay? Last one, I think. All right, in this graph, P is the point with the x-coordinate of 2. So this is 2 and something. The tangent at P has a gradient of 1. So in other words, we know that f prime at 2 has to come out to 1. Find a. So a is this original equation, in the original equation, and it's right there. And I can find that if I know an x and a y. Well, they didn't give me the point P, they gave me the x part, but not the y part, so I can't use that. But in my derivative, they gave me an x and a y, so I could probably use that to solve for a. Let's give it a try. So let's take our derivative. Y prime equals 3 halves x squared minus 2x plus a. Now we can plug in the point that we know. We know at f prime at 2 comes out to 1. So 1 going for the y. And we can put the 2 in for the x in both places. And then all we're left with is a. That's kind of handy. 3/2 times 4 will give us 6 minus 4 plus a, or 1 minus 6 plus 4 is a, so negative 1 is a. Now we found a. Now we're going to find the coordinates of point P. Well, point P is at 2 and something. And the only thing we couldn't find originally was when we had that a there, right? So we can now plug in our x value of 2, our x value of 2. Our a value is negative 1 times 2 plus 4. And just put that on your calculator and you should end up with 2. So point P is 2, 2. Okay. Part B, find the equation of the normal at P. So the normal at P. Well, the normal goes through P, which we know is 2, 2, at a perpendicular. Well, we were told that the tangent has a slope of 1. So the perpendicular, the normal, will have a slope of the opposite, negative 1. Using those two things, we can find our equation of our normal. So 2 for y, 2 for x, solve for b. We've got 2 plus 2 is b. b is 4. So y equals negative 1x plus 4. Okay, part C, find the coordinates of the point Q where the normal meets the curve again. So if I were to draw this, normal is going through. Now it's kind of hard to tell here, but my normal is going through a triangle. I'm going to go through that line again. Maybe there. Well, I draw maybe there again. I got to figure out where that happens. How can I do that? Well, I can do that by taking my normal, which is this equation we just built here, negative 1x plus 4, this is part C, and figuring out where it meets the line, where it meets the original equation. Our original equation was given as 1/2 x cubed minus x squared minus x plus 4. I want to know where those two things meet, where they're the same. So let's solve this. Let's put everything on one side. We'll get 1/2 x cubed minus x squared minus x plus 4 plus x minus 4. And we may notice the 4 and the 4 cancel, the x and the x cancel, and we're left with just 0 equals 1/2 x cubed minus x squared. I need to solve that. Well, I can solve it by common factoring, first of all. So I'm taking an x squared, I'm left with 1/2 x minus 1. So it meets at x is 0, and it meets at 1/2 x minus 1 equals 0. In other words, x is 2. So these two lines, the normal and the original curve, meets at the points x equals 0 and x equals 2. Now, if we go back to the picture for a second, we already knew that it met at 2. That was point P, right? That's where x is 2. Turns out the other one is where x is 0. So it actually meets right there. So what is that point? Well, if I put 0 back into my original function, sorry, on the bottom here, if I put that into my original function, in other words, figure out f at 0, I'll get 1/2 times 0 cubed minus 0 squared minus 0 plus 4. Oh, the point is 0, 4. That's Q. Oops, there's no F there, sorry. Get rid of that F. And the point 0, 4. Okay, and the last part, find the equation of the tangent at Q. I want to know the tangent at Q. Okay, so what do I know about this tangent? I know this tangent goes through the point 0, 4. And I know it's perpendicular to the normal. Well, the normal, we just found out a second ago, the normal was negative 1, right? So what's perpendicular to negative 1? Well, it's back to 1 again. Okay? It's the same tangent as the original one. These two things, these tangents, have to be parallel to each other. Okay? So if I use those two ideas, I got my slope, I got my point, I can make my equation. Now, nice equation here, if you didn't notice, is that when I put 0 in, I've already got my b. My y-intercept is just 4. So my equation is y equals 1x plus 4. Okay. And there is our beautiful equation. Sorry, no typo there. That's -1. Okay, that's the end of tangents and problem solving. When you do the homework, just for number 15, it doesn't say it, but try and find the normal for me, just to get a little bit of practice doing that.